Good evening, everyone. Welcome to this live revision session for the course Nanotechnology and Agriculture. So, what today we will be doing is we'll be from assignment 1 to 7. What we'll be doing is we'll just go through the important questions and the important concepts that are there so that it can help you in navigating the exam more efficiently. Uh, we are anyway very near to the exam. Exam will be this weekend, I think so. I like I wish to give you a basic brief introduction. If you have any questions, if you have any queries, you can we can do it today. Tomorrow we will be doing the week 8 previous year questions, so we can do that also. Tomorrow also we can do it. So whatever you have the questions, you can just give out your questions. We'll start with the session. We'll just wait for few more minutes and we'll start with the session. Just 1 or 2 minutes, please. Okay, so let's start. Um, Good evening, everyone. Welcome to the live revision session. My name is Amil Singh. I am a Prime Minister Research Fellow in the Department of Mechanical Engineering, IIT Tirupati. The course instructor for this course is Professor Mainak Das. He is the professor in the Department of Biological Sciences and Bioengineering, IIT Kanpur. Before we begin, like always, this live interactive session is to boost your performance. It is not compulsory, but it is highly encouraged to attend. I request you to be respectful in the chat, and you can ask your question at the end of the session. So, what we'll be doing is today I'll go through all the previous year question assignments, and whatever are the important questions, we'll solve only those. Then we'll move towards your question and answers. This is a 8 week course. These are the week wise topics. So in the first assignment, you should understand, you should remember these kind of like important scientists, whichever have been named in the lecture slides. In the lecture slides, few scientists have been named. So those things, those scientists' name we need to know. So in the first question they had asked, Dash is successfully synthesized nitrogen and hydrogen into ammonia during the early years of the World War One. J.B. Boussingault, Justus von Liebig, Fritz Haber, J.H. Gilbert. So the answer was Fritz Haber. So this is the Haber process. So wherein they use nitrogen and oxygen, and then using some catalyst, they prepare ammonia, which is a very important fertilizer. So that is why these kind of processes you need to understand. Then, second, what type of questions you can be asked are the native plants. So basically, these are for your benefit. These will be very basic questions. So this is the fourth question we had in our zero assignment. That is, the potato is the native of dash Asia, North America, Australia, South America. So the answer was South America. And see, this graph maybe few things which are there like rice, sugar, tea. Um, then whichever are there like very important plants and animals which we plants basically which we have in our day-to-day diet, you need to remember them. So please keep a note of it. Most of the I can say if there is an option, uh, if Colombia is an option, just select that, because as you can see here many of the things have actually come from Colombia. So you can see from this arrow, basically maize, potatoes, tobacco. So it can be either South America or Colombia. If you have either of the two options, this is just a hint I'm giving you. So if you are confused, and I'm not telling you if you don't, only if you don't know anything, and if you have to take a chance, maybe you can take a chance on Colombia or South America. That is something which I can say. Like if you are only if you are confused, if you know the answer, use the right answer. If you don't know the answer, And if you have to take a bet on something, then you can go with Colombia or South America. Then the next set of questions will be on the MEMS fabrication or the nanoparticle fabrication technique. So in the fifth question is basically the physical vapor deposition. PVD is widely used technique for the dash and surface coating, fabrication of thin films, plasma cleaning, surface etching, chemical etching. The answer is fabrication of thin films. So this is the PVD process. PVD is a very important process. You can various type of question can be asked on PVD. So just I'll just refresh you what how the process works. So there is a vacuum kind of chamber which has argon gas as the conducting gas. Then basically argon is ionized. So once argon is ionized, the argon in the ionized state goes and hits the sputter target. Sputter target can be any metal. Bear in mind, it will only be a metal. So, so argon will go and hit the sputter target, which can be gold, copper, or something, a metal, and then it will go and hit the polymer will be ejected from the sputter target, and because of their potential difference between the substrate and the target, what will happen is the sputter target atoms will go and hit the substrate forming a thin film. So that is there. So one thing, so the sputter target. So questions can be asked on the what is the conducting gas. So the conducting gas is argon. What type of sputter targets can be there? So sputter targets will always be metals. There will never be a polymer sputter target. And how what causes the atoms to uh, go towards the sputter target towards the substrate, the silicon wafer? The answer is the potential difference. Okay. Then you had have this kind of questions which are like basic questions regarding cosmetics or something like that. So in this question, it is basically dash nanoparticles are used in sunscreen, diamond, pyrite, titanium dioxide, mercury. So the answer is titanium dioxide. So we basically coat the titanium dioxide nanoparticles with melanin, which is a biological pigment, and then we apply the sunscreen on the surface, and due to the size, the titanium dioxide nanoparticles penetrate through the surface, do not penetrate through the surface, and basically they stay on the surface. So that is why it is safer than other sunscreens also. Okay. And like this kind of like very basic GK type of questions can also be coming. So like in which state in India do you find floating gardens, or which state has the maximum production of sugar cane? Like basic questions. You may know it. You if you don't know it, like take a wild guess. I am quite sure that it will be something that sir has spoken during the class, and if not, you can even contest that question. So if the question is very wide, you can even contest it. So uh, which state of India do you find floating gardens for growing vegetables? Uttar Pradesh, Arunachal Pradesh, Jammu and Kashmir, Kerala. The answer is Jammu and Kashmir. Then these kind of basic questions can also be asked. Based on the chemical composition of organic manures mentioned below, which kind of has the highest nitrogen content? Hair and wool waste, bone meal, poultry litter, cotton cakes. The answer is hair and wool waste. Then this kind of question can be asked like list a process and they'll ask whether it is a top down or a bottom up process. So it can be done with like since we have various nanoparticle synthesis preparation process like ball milling, soil gel, laser, and all the other things. So they'll ask what kind of process it is. So you have to find out how it is. So Soldier method basically it's a bottom up process. You have a salts of both the materials you want to make a nanoparticle, then you dissolve it in a solution, and then you let their gel being formed, and then you get the nanoparticles. This is how the process works. So these kind of questions can be asked in case in terms of question in terms of first assignment, week one assignment. The question like the question number six is important. Like the question is ammonia is synthesized requires a temperature of 100 degree Fahrenheit, 200 degree Fahrenheit, 400 degree Fahrenheit, 800 degree Fahrenheit. So the answer is 800 degree Fahrenheit. So these kind of questions. Then the next type of question that can be asked is one zero dimension, one dimension, two dimension, three dimension nanomaterial. So these are also very important questions. So as we know, nanosphere, zero dimension, none of all of the sites x, y, and z are within the nanoscale. One dimension, one of the axis. So either it will be x-axis, y-axis, or z-axis. One of the axis is more than the nanoscale. In 2D, two axes, so either x, y, or y, z will be out of the nanoscale. So like two of the axes will be outside the nanoscale, and in 3D nanomaterials all the three axes will be outside the nanoscale. So but the minimum feature size in the 3D nanomaterial will be in the nanoscale. So you will have the properties of nanomaterials, which are the high surface to volume ratio, so which gives out the nanomaterial type of properties. So that is what a 3D nanomaterial is called. So in the question here it is asked in dash all the three dimensions of their nanomaterial are in the nanoscale range. Nanoparticles come into classification zero dimension nanomaterial. Then coming to this kind of question, so ZNS, like what kind of semiconductor it is. So basically identifying what kind of semiconductor it is. So these kind of questions have been asked in various assignments. So I think we should focus on this kind of like uh, like understanding of what semiconductors are, how the semiconductor naming works, N type, P type, group, and all these things. So we need to find out. So for like here, since in this kind of questions you will not be as very in depth, you will be, it's not like now you are being given here CuLnSe2, you will not be asked whether it is a 1,4 or a 3,4, that kind of things it won't be asked, because that is too much in depth. But what you will be asked is you will be given a material and you will be asked to find out what its group is. So the simple logic is basically if there are two elements it is a 2,4, if it is a three element it is either 1,4 or 3,4, and if it is a four element it is either a uh, 1,2,4 or 1,3,4. So that way it is, you have to find out how it is done. Then coming to like semiconductors, again it's a very important topic. uh, so you have to like some options on semiconductors. So basically what is a semiconductor, you have to, I'll just explain you in brief, so you'll be able to maybe solve a question that might be related to semiconductors. So the first thing is basically there is something as a conduction gap. So conduction band and valence band. So basically, whenever the electron is in the valence band, so basically it is the outermost electron that can be donated or um, yeah, received, right? We here for a basic understanding, we'll just talk about receipt that can be donated. So basically, what happens is in the metals, the outermost electrons is in the that is there in the valence band does not require much energy to actually travel to the conduction band. So basically, the valence band and the conduction band are basically very close together. So what happens is you don't need too much of energy for the metal on to start becoming a conductor. So that is why it is called as the that is how the conduction band looks in conduction band and valence band look in metals. In terms of bulk semiconductors, so there is a small gap. So you might have seen in the experiments. So you might have done some experiments with the Zener diode. So you'll see that there is some amount of energy. So there is the voltage has to be given, and then there is something called a Zener breakdown voltage. So after the breakdown happens, the semiconductor becomes a conductor. That is how the conduction works in bulk semiconductors. In small scale, in when you go into the quanta, what happens is the energy band becomes quantized. So uh, when the energy band becomes quantized, so the amount of energy that is needed becomes higher, because the energy gaps here, uh, because there is a bulk, there are too many number of atoms. The uh, This becomes a band in terms of metals or bulk semiconductors. But when you go at a nanoscale, when there are atoms considered, each atom, the energy band will be quantized. So based on that, the uh, band gap changes. That is how more energy is required in terms of nanomaterials than nanomaterial semiconductors, or you can say quantum dots, compared to bulk nanoparticles. That is why the quantum dots or nano scale semiconductors have more band gap energy compared to normal semiconductors. Okay, so in this with this you can know what semiconductors are. So uh, here the question was, semiconductor nanomaterials have dash properties. They exhibit wide band gaps by modifying them to show different properties: metallic, metallic and non-metallic, non-metallic, metallic, non-metallic. Yes, so the answer is metallic and non-metallic. So these kind of questions will also be coming. So again, this one was about the classification into zero dimension and one dimension nanomaterial. This kind of statements can be coming. So you can solve these kind of questions as well. So I won't delve into this. I just list out these questions because these are important ones. So you can just have a look at this question. Okay, we are here. This is a revision session. We are mainly based upon the concepts and not solving each question, because I am more focused on giving out the concepts now. So again, as I said, nano composites, core shells, multi-layer nano layers, bundle pairs are categorized as uh, three-dimensional nanomaterial. So we discussed that earlier as well, and now also I gave you in brief. So basically, what happens is, even though the size of the entire bulk, so the size of the nanocomposite might be higher than the nanoscale, the feature size is in the nanoscale, and that gives out the nano properties. So basically, you get the high surface area to volume ratio. That is the main major property at the nanoscale range, and that is how these are called as three dimensional or bulk nanomaterials. These kind of questions can be asked. So basically about fullerenes, diamonds, and all those things. So how the structure look like. So this is how a fullerene looks like. So it is a hollow cage type structure. Then these kind of questions can also be asked. So these will be like to confuse you about testing your knowledge of oxidation and reduction. So you need to, like, maybe if you get time, go through some good video which explains you redox reaction or in details, how what is reduction and what is oxidation. If you understand it, you will be able to understand. So reduction is basically oxidation state it reduces. So what happens, whether the electron is taken in reduction or whether not. So basically what happens is, in the reduction phase, electron, so if anything is getting reduced, so what is happening is it is taking electrons. And when in the oxidation phase, there is a loss of electron. So you have to understand that. You have to maybe go in depth here. What kind of reaction occurs, you need to understand that, and these kind of questions should be asked. As I said here, graphene and graphene oxide, reduce graphene oxide. That is also a very important question. So in the first 2 weeks, any questions? If not, we'll move to the next. So as I said, the processes are very important. PVD, CVD, um, then here um, the Langmuir logic, film formation, and those kind of questions. You need to understand these processes, and questions might be asked on this kind of process. Main among them is always PVD, and because that's a simpler process, and it has been discussed in detail in this syllabus. So language logic information. So basically, it is asking how which process is applied for synthesis of ultraviolet film and surface coating. So the answer here is PVD. Then again, as I said, ball milling, a very important concept. Sol gel, ball milling, important concepts. Ball milling is a dash method to fabricate nanomaterials. It is a mechanical method. So next, week 4, gadolinium, very important syllable, very important part. Uh, what is see? You have had two assignments in which gadolinium has been asked to you. In various other with gadolinium and its application are asked to you in various forms. So you need to know. You need to know how many electrons are there in which orbit, what is its magnetic behavior, what is its how it functions inside your body, why is it used, and other applications. So gadolinium is a very important like what we can say very important part of your syllabus, you can say. Okay, so dash are tagged with gold nanorods for MRI diagnostics and images, gadolinium. So this is how it works. So these gadolinium is just coated on um, the um, coated on gold nanorods, and then it is ingested into the body. When it goes at the tumor, it is gives a better contrast. So it is basically used as a contrasting agent. Then these obviously we are talking about our agriculture. So monocot, dicot, these kind of questions will obviously show up. Uh, I am quite sure most of you are from agriculture department. So these kind of questions will not be a difficulty for you. Uh, mm, what where you might get stuck is basically the nano part, not the agriculture part. So these kind of questions, obviously, I'm quite sure you'll be able to do it. So I will not discuss these kind of questions in detail, but I'm quite sure that you'll be able to understand it. So these kind of mechanical testings, these three tests, I am quite sure one question might be asked from this test. So understand what is going on here. Punching, basically you test how much force it can withstand in a single punch. In the tearing test, basically you measure the shearing strength. You measure the shearing strength of the material. You measure the tensile stress of the material. You apply the load in the normal direction. In the shearing test, you apply the load in the transverse direction. So the tearing test measures how much force it can absorb before it is broken down. The shearing test measures how much stress it is needed to tear apart the leaf. because the structural rigidity of the leaf is very important. If the leaf structural integrity is affected, it's of no use for us. So that is why we are doing all these tests. These are one of the important questions which I have seen. The drought resistant also. So focus on these type of questions also as well. So we'll do these questions, and I think so. These questions need a revision. So anyway, we are halfway through the revision. So I just think that these are important questions which I think so need revision. So we'll just go through these questions one after one by one in a rapid fire mode. So question number four: a drought resistant plant develop tighter cell walls, cuticles, aspirine strips, and other barriers that help minimize dash during the dash condition. So whether it is to minimize the nutrient loss during scarce water condition, water loss during low water condition, gas loss during scarce water condition, ionic gain, or during scarce water condition. So obviously the barriers are made to reduce the water loss due that can happen due to evaporation during the low water condition. So that is how the drought resistant plant work. Um, the next question is some of the essential factors of the soil, such as organic matter and humic acid, make nanomaterials which dash. So basically, it is asking these organic matter, do they make them less stable, which makes them their decreases their availability, ionically stable, that enhances their ionic activity, more stable, that enhances the ability to generate free radicals, and more stable, that it enhances their bioavailability. So the answer is more stable, it enhances their bioactivity, bioavailability. So basically, what happens is this organic matter and humic acid basically make the nanomaterial more stable, which what happens is um, in keeps the nanomaterial intact, so it doesn't let the nanomaterial break down into its ionic form. So if the nanomaterial breaks down into ionic form, the work it will do is it will be different than what will happen when it is in a nano form as such. That's a nanomaterial, its integrity is intact. So basically it enhances the bioavailability. Question number six: the transport of copper oxide nanoparticles from root to shoot and its reverse transport from shoots back to root take place via xylem and phloem respectively, xylem and water channels respectively. So the answer is xylem and phloem respectively. So this is how the transport of copper oxide nanoparticles looks like. Okay. So again, this is uh, you guys are expert in this. What is the uh, difference in the leaf architecture of a monocot and a dicot? So you all know about it. The monocot leaf has a dumbbell-inspired stomata, and the dicot leaf has a kidney-shaped stomata. So yeah, so these are the next important chapters, which is the characterization technique, XPS, SAM, uh, XRD. Um, the techniques that have been mentioned in the course are very important. SEM, TEM, XRD, XPS, FTIR, I think so. So these are very important techniques, and again, vibrating sample magnetometer has also been discussed. So these techniques are very important. So magnetometer, if you see, then we have to understand that it is only for the magnetic material. So if there is iron or something, then only you can put in the magnetometer. Other materials like copper and all, they don't work in, they are non-magnetic in nature, so you won't get any, the magnetometer is of no use. So just keep that in mind. So assimilation and concentration of iron nanoparticles in pumpkin plants were quantified by employing a dash to confirm the functional presence in the roots and leaves. So the answer is vibrating sample magnetometer. So you wanted to, so since you want to get magnetic material, you want to extract it, you want to confirm its presence, you are using a magnetometer. So again, the question number 9, the major problem with tracking and translocation of ferrous oxide nanoparticles is associated with the inability to distinguish between intact ferrous oxide nanoparticles and leached ion, which can be further solved by utilizing magnetic particle spectrometry in conjunction with conventional atomic absorption spectrometry, XRT in conjunction with XPS, time in conjunction with XPS, XPS in conjunction with FTIR. So magnetic ion is there, magnetic is there. So there is a good chance that it will be a magnet will be used. Okay. So these are the like, so these questions. So you can see the statement type of questions. These questions are basically there to test your common sense also. So sometimes it is like this is a common sense based question. This has like you cannot bracket them into any like characterization technique or preparation technique. So this is a very basic kind of question. So the ability of nanomaterials to penetrate through hard coating of the seeds and allow water transportation is the deciding factor for increased growth and vigor. Uh, in addition to seed priming techniques, with the help of nanotechnology, it is a promising strategy. Before sowing, it is further corroborates the potential of high yield value crops. So the answer is both statement A and B are correct. So moving to, sorry. So in 5 and 6, basically, we didn't have too many questions of very important. So obviously, you are requested to go through it. Uh, we'll directly move to week number 7. So these kind of questions can be asked where you will be given some like source of titanium and plutonium, and you will be asked to identify what it is. So illuminate, here is the composition. You can see it has both ferrous and titanium. It is mainly used for titanium extraction because we are talking more about titanium. So again, this is very important concept, the zeta potential concept. So as I said, it gives about the stability of the nanoparticle. So this is how the concept of zeta potential works. So basically, what happens is when you have a material, the charge that is caused by the electron is coming on the surface of the material. So you use a surfactant to stabilize the charge. So when the nanoparticle is there inside the surfactant, so for every charge, there will be an opposite charge that will be forming on the surfactant. So when you have an ionic surfactant, ionic charge will be formed. So the charge will be formed in the form of a electrical double layer. So there'll be like three types of layers. So what will happen is the zeta potential is basically the what it does is measures the electrical double layer. So the electrical double layer, what is formed, is equivalent to the surface charge. Okay, so basically the charge is formed. The charge cannot like exist in single. Like we'll never have a single positive charge there. We'll always have a positive and its complementary negative charge coexisting. So it is very difficult to isolate a single charge. Okay, so that is how it works. So what will happen is by measuring the electrical double layer, you find out that how strong the nanomaterial is. So that will be the amount of energy that will be required to break down that nanomaterial. So higher the zeta potential, higher its stability. So question number 3. Uh, Dash works as a nanocatalyst in the degradation of methyl orange dye. So these are like very uh, like GK type of questions where you need to know the syllabus, recall kind of questions. So this is how the mechanism works. So uh, basically, the photoanalysis, it activates the surface, and it leads to reduction of the methyl. Then again, gadolinium, as I mentioned, where it comes from, it comes from the lactinide series, and what is its atomic number, everything you need to know. Again, periodic table actinides is from 90 to 103. These are like the biological models, so sliding filament models and all those things. These are also important, but not like you can expect like very simple questions from this. So how the sliding filament theory works and those kind of questions. So here it is, based on basis of the understanding of muscle contraction is the dash first proposed in 1954 by Audrey Huxley and Ralph Niedergerke, and by Hugh Huxley and Ian Hansen. Excitation contraction sliding filament theory, topological mode, excitation sliding model. So the answer is obviously sliding filament theory. This is how it works. So basically, neurons emit ATP and calcium once the calcium is released. So depending on how much the calcium and ATP are released, the filament will go on sliding over bleach. The muscle is basically broken down into a number of filaments. That is how it works. So here the answer is the contraction skeletal muscle is triggered by nerve impulses which stimulate the dash, that is the release of calcium, and based on the calcium, the entire chain of event works. Question number 8. It has been observed that ZNO can be demonstrated likewise in the dark, inhibiting the bacterial growth. So, antibacterial activity. This is how the antibacterial activity of ZNO works. It releases reactive oxygen species that reacts with zinc. It releases zinc ions, and it also comes in direct contact with the cell membrane. So basically, when it releases a reactive oxidative species, it creates oxidative stress, which bursts the cell membrane. Zinc ions basically interact with the sodium potassium pump. As I said, sodium potassium pump is a very important pump that is very important for the cell functioning. So it impacts with there, and it also goes and directly pierces the bacterial cell membrane. So it has a three-pronged strategy, so which increases its microbial activity. So that is why it is being used in human medicine also. This is some like questions like nano liposomes. Why are they used? So basically, they are used as nano carriers. So uh, you load the nanoliposomes with the drug. The drug penetrates the skin and basically releases the material. It releases the drug and it saves your skin. Um, Again, type of finding out what type of process it is. Nanomilling is dash process, which by which industry can minimize the on the nanoscale the size of poorly water soluble active ingredients, increasing the surface area and consequently increasing the rate of dissolution. So it is a top-down approach. So let me summarize the entire thing for you. We are talking about the important questions today. So first and foremost, find like the basic questions like origin of the species, like origin of potato, origin of rice, and all those things. That those kind of questions. Then second, the questions related to uh, what like some Indian GK, like which state has what and which state has is famous for this production, that production. That are like something specific to India. So Indian GK kind of questions. I would suggest skipping them because you can never study all of them. So study what is there in the syllabus, but don't waste too much of your time on that. The third and the most important thing, zero dimension, one dimension, two dimension, three dimension nanomaterials. So that is a very important thing. Um, The next one is the processes, solder process, ball milling process, nano milling, and those kind of things. So that is a very important thing. Then next, um, uh, the characterization technique, such as like what is XRD, FTIR, SIM, TEM, those things. Um, Obviously, it's a agriculture course, so the monocot, dicot, but I think so. You guys are expert in that, so I don't think you will be you will have to worry about that per se. Then gadolinium, obviously gadolinium, how what are its properties, whether it is paramagnetic, how many electrons it has, which group in the table it acts, why is it used in medical application, that it is used as a contrasting agent, it is used also as a drug carrier. Those things you have to study. And um, last thing is, as I said, the processes, characterization, gadolinium, uh, um, uh, 0D, 1D, 2D, 3D, and like GK kind of questions, and basic things which have been given in the lecture notes. So if something has been given, or if the sir has spent uh, more than a specific time emphasizing something, then it there is a good chance that it might be asked during the class. Okay, because the question paper will be said by sir. So obviously, if sir has spent some more time on uh, explaining you something or emphasize on something, there is a good chance that he might ask you that. Okay. So, do you have any questions? Do you have any questions? Yes, sir. Yes, Deepak.
No. Tomorrow there will be also an online class.
So tomorrow is basically the week eight class for week eight. There won't be much discussion. So today is basically the revision session. Tomorrow is just the scheduled class for the week eight, and tomorrow will be the last class. This is just to give you a brief overview of what you can expect in the exam today's session. Tomorrow is just the week eight content which will be done. So tomorrow there will be just discussing the 10 questions of week eight, and that's it. So if you have any questions related to other weeks, so week 1 to 7, today is the good time to ask. Tomorrow also we can take, but I would just suggest that like for from the exam point of view, today's session I'm just giving you a like what to study and what you should more. I'm just giving you out the important questions. That's what I'm doing.
Can you go through the last worksheet with 6 or 5?
What? Pardon?
Just take
Can you repeat yourself, sir?
week 5 and week 6.
Week five and week six. It's that that's why I'm skipping. Is that it has like whatever is important. I have given that. So if you want, I'll just open the slides and I'll show whatever we did in the week five and week six. But I think that is not very like. So I just gave you what is important. Week five is basically the carbon nanotubes and all those things. So
Current
obviously,
assignment, sir.
yeah. So that is more of like I thought you will be knowing it. So I just gave on the important ones. So yeah, I can go through week five and week six if you want. But like I didn't like I was just brushing up, so I did not give it to you. So I can do week 5 and week 6 for you if you want. I can do it right now. So if you have any other questions, you let me know. I'll start with week 5 and week 6. Don't worry.
In this, there is some doubts, sir, but
Yeah.
I cannot remember this time because I am in my working place. If you
Okay.
are agree to discuss with me tomorrow, then it will be better. I would write down the problem.
Yeah, yeah, we can do it tomorrow. So the thing is tomorrow, yeah, we can do it tomorrow also. No worries. So you can just come up with all. So that's why we have this questions sessions one after the other. So you can come up with all your questions tomorrow. No worries. It's uh,
Okay,
it's
it's
completely
okay,
up to
okay,
you.
sir.
So do you want me to go through question five
Sir,
assignment 5 and
I have only one question, sir.
yes sir,
Through the PBT,
yes sir.
can we can we make any solar film
Through what sir?
through the
PVD,
PBT?
physical vapor deposition.
Yes,
No, sir.
solar voltage.
Photovoltaic cells, you're
Huh?
asking, right? So, no, sir, because see, the thing is, what the photovoltaic cell is basically a semiconductor. So, for that, you need there has to be a electron band gap. So, how it works is basically the photoelectron basically um, hits the material, and then it excites the electron and it goes into the conduction band, and it is basically it generates the current. That is how the photoelectric how the uh, solar cell works. So the photoelectron that is coming from the sun, it hits the material, it hits the semiconductor material of your photovoltaic cell, and it generates electricity. But basically with PVD, what happens is atoms are deposited. So a gold atom will be deposited um, on the substrate. It is not a semiconductor anymore. It is a gold atom has been generated, has been stuck. So with PVD you cannot make the photovoltaic cell, because PVD deposits a atom film, atomic film. It is a pure material. It is not a semiconductor. So as I said
Okay.
earlier also, PVD is mainly used for metallic film deposition. It doesn't
Only
alter
metallic
the
film.
yeah, it doesn't alter the chemical composition of the substrate. It just stays on the substrate. It makes a layer on the substrate. It doesn't alter the chemical composition of the substrate.
Okay, okay, sir.
You understood the difference between
Yes,
the
yes,
concept?
yes, sir. Then I quit, sir. I will discuss it tomorrow.
Yes, sir. Sure. Sir. Have a nice day, sir. Anyone? Anyone has any other questions? Do you have any other questions? If not, you are free to leave the session. Any questions? If you don't have any questions, you are free to leave the session. Any questions? So, for the people who joined right now, so I'm just what we did today is we basically summarized all the important questions that will be there in the exam. So, just to summarize all the important topics that you need to know for the exam is basically one, um, you need to know about the origin of the species, so where each plant is coming from, some India specific GK where this institute is, which state grows. Like which plant highest production of the plant, etc., etc., kind of questions. Then the third and the most important thing is basically 0D, 1D, 2D, 3D nanomaterials. That is one important thing. Then you also have to you can expect answers, you can expect questions on the type of nanoparticle fabrication method, whether it is top down or bottom up. Like sol gel method is a bottom up process. Ball milling, which is a mechanical process, it's a top down process. Those kind of questions you can expect. And the last and most important type we can expect is basically the characterization techniques, XRD, FTIR, SEM, TEM, EDS, those kind of questions. And then more or less you can expect questions on gadolinium, its electronic configuration, whether it is paramagnetic, ferromagnetic, and how it works. And the most important question point will be how it works in medical application, whether how it works as a contrasting agent, what how the functioning happens. So those kind of questions you can expect more or less in the exam. So if you have any questions, you can unmute yourself and ask. uh, we basically summarized it. Tomorrow we'll be doing week 8 questions again, and week 8 questions for previous year questions, and we'll be concluding with the course. So if you have any questions, please unmute yourself and ask. If not, we can see you tomorrow.
Hello.
Yes, sir.
Good evening, sir.
Yeah, good evening. Good evening.
Sir, where do I get the recorded video like this lecture? Is it being recorded and the link is being shared somewhere through which
Yeah,
I
yeah.
could?
So if you go on your course page, you can see like week 1, week 2, week 3, week 4, week 8. You can see right on the
Yes, sir.
left side. So at the end, there is something called as problem solving sessions. Over there, you will get you will get a link which will open a Google Sheet, which will have all the links of the videos and also the PPTs. So what I would suggest is don't go to the videos. Videos are anyway it will be time consuming. So just go through all the PPTs. You have a drive link which has all the PPTs there. So just open those PPTs, skim through all the PPTs, and you'll be done with the done with the revision of the session. So for your quick revision, just go through all the PPTs. I can, if you want, I'll just show you how it is, how you get it. Just a moment, just wait for me. I'll share my. I'll just share my entire screen right now for you. So I hope you are able to see my entire screen. So you go to your
Yes, sir.
NPTEL course. You go to my courses. So obviously sometimes you get auto logged out, but you can just go through it. So you go here, you go into my courses. Um, so you go to the course nanotechnology in agriculture. Once the course page opens, here at the end you have problem solving sessions. So you go here, open it, and these are the video links. This is the drive folder. So what I would suggest is go through this drive folder and just like week 5 I think so is missing. I'll add it right now. So just go through all the presentations, and that will be sufficient for your preparation, because rather than spending 20-30 minutes on one video, with this you can finish in 20-30 minutes, you can finish all the week revision. Okay, any
So,
question?
so these PPTs have the
Yeah,
level of questions that might be
just
asked
a
in the
moment. Yeah,
exam.
yeah, just can you just speak again? Hello, can you repeat
Yes.
your question?
So I just want to know what would be the type of questions asked in the exam. Like it would be the same as the assignments, the questions asked in assignments, or the ones that would be present in the PPT.
So the thing is, it will what is being asked in the assignment and the one is in the PPT. It's like uh, you can treat it as a question bank. So all these different kind of questions can be asked. So the thing is, these question bank or the PPT have been made by a student. The question bank also, the assignments which you are seeing are also made by the student, but the final paper will be made by the professor. So you can expect a mix of both the things. So one thing, it will not go beyond the scope of the course. So whatever has been taught in the course, whatever is there in the syllabus, only that will be asked. Many times in the assignments, there have been questions wavering out from the syllabus, but that will not happen in the exam. The questions will be within the syllabus, and you can expect like single MCQ questions from the important topics as I mentioned earlier. The characterization technique, fabric, like production technique, production method, soldier method, ball milling, those kind of questions. 0D, 1D, 2D. Then um, that that is done. Later, as I said, some GK questions about like what which institute is where and all those things. Then the origin of the species, gadolinium, which is how the gadolinium works, and the processes. Main thing is the processes, like PVD, CVD, those kind of processes, and the characterization technique, XID, FTIR, SEM, TEM, those kind of things. And agriculture related questions obviously will be asked. I'm assuming most of you are from the agriculture background. So um,
No, I am from BTech biotechnology with specialization in medical. So
okay. So yeah, focus more on the medical part, like gadolinium and those kind of parts. You focus more on that, uh, and try to go through all this, like agriculture related, whatever is there. You can recollect it. Like if you have time, then study all the slides in detail, all the like lectures in detail. Just go through all the source video, week 1 to 8, and maybe you'll be able to score well. But focus more mainly on the gadolinium part, because that is the medical part per se.
okay, sir. So, is it wise to go through all the videos at this point of time, or I should go through the PDFs that is uploaded by sir, like the
Handwritten ones.
notes, yeah, the handwritten notes?
uh, See, thing is, if you go through all the, actually, people would say it is advisable to go through the videos, but you don't have the time. Obviously, we know that. So, go through the handwritten videos, revise the assignment, this year assignment, and the PPTs which I am uploading once again, and go from week to like whichever. If you don't understand the handwritten PDF at all, then maybe go through the videos. I would suggest.
Okay, sir. Thank you so much.
No problem.
Okay.
If you have any questions, yeah, you can ask. If you don't have, you are free to leave the session.
Okay.
I wouldn't take your time. All the
Okay, sir.
best.
I'll sign out. Thank you so much.
All the best. Are there any questions? If there are no questions, we would like to. I'd like to thank you all for your presence, and we'll see you tomorrow. So, thank you.